Friends, so today we are solving this problem, fruits into basket 3. So we are given two integers, fruits and basket. So fruits is like there's a size of every index there are certain fruits, okay, of type ith index, okay, that is one thing. And baskets is like another array which has like the capacity of that basket on any ith index. So you can consider like this is fruits. So fruits are like these are the amounts of the fruits sitting at at any index, ith index. So every index is kind of a type of fruits, and this is the basket capacity. Okay. So for example, here this is very first fruit. So we have to put it somewhere, the very first one in this. Okay. So when we'll take this 4, we'll check that hey, is there some capacity which is greater than or equal to 4? So see here, this is the first one. So we will place it. Now this capacity in basket we will update 0, right? And similarly for we will go for 2. So we can place in at very first place. Now coming to this final one 5, we have like this is already filled, second one is already filled, but 4 has capacity less. So we can see that one of them like 5 is not able to place here. So only one type of fruits we are not able to place. This is what we have to do. So it looks like when I explained it, we can one by one search it, and whoever is available we will put the fruits and make the capacity, but this will take time complexity O of n square, right? Because we will check for every fruits from here and check for the first available capacity. So in part 2 of this question it was accepting with this approach, but we will not go in this approach. Okay, we can do the search based upon the range. So we will go into that solution, but before going to that solution, we will detailed understand what is the segment tree, why do we need it, what is the use of it. Of this question, we have the max criteria. So this is our nums, nothing special so far we have done, but we want to make this max value range based. Okay, so you can observe here that if starting from 0 and ending 7, what is the max here? Max is 90, right? I can write here 90, correct? So similarly, this could be any range. For example, let's say 0, 0. Between 0 range, what is the max? So 0 means 10. So 0 to 0, it is 10 only. So we can write here 10, right? Similarly, we can write what is the max range between 1 and 1. 1 and 1 is this guy only, right? So we can write here 20. Now, if we look for what is the range for 0 and 1, so the range between 0 and 1 would be whatever is the maximum from this bottom, right? So we can say like this. So whatever is the maximum in this way, that would be coming to here. So what is the maximum here? 20 is maximum. So it will go 20 here. Similarly for everywhere it will go. We will take the max of this guy and max of this guy and put it here, right? Similarly we are taking. So you guys can observe this is an example of segment tree. Okay. Now we will talk about bit about segment tree. So you can see here, this is nums is 8 size tree. Right, there are 8 values only, so this is 8 sized. But if you can see here, what is the size here? So this is our segment tree. Segment tree has size equal to 2n minus 1, means 8 into 2 minus 1. There are 15 nodes total. You can see here all the leaf node that doesn't have child, how many they are? They are total n, right? I mean the 8 in this case. So 8 are leaf node, and those who are non-leaf node, they are total 8 minus 1 means 7. You can see here, right? These are the 7 nodes. So you can observe one thing here, that if this size is n, then our segment tree would be having 2 into n minus 1, right? In this case 8 into 2 into 8 minus 1. So 17 are the total nodes here, and leaf node would be equal to n. So total nodes would be 2n minus 1. This is first thing. Now you can see here, we have splitted this range. You can see here 0 to 7. Okay, 0 to 7 is covering entire array, right? Then we are getting the mid of it. So 0 to 7, 0 plus 7 by 2, it would be 3. So this range is coming from here 0 to mid. Okay, and this range is coming mid plus 1 till whatever is the end here, like 7 is the right pointer here, and so on. We are dividing this. Okay, now what is the benefit of it? You might have a question that why do we need all these things? If somebody is asking you what is the maximum between 3 to 5, then we can come directly here 3 and then we can traverse here till 5, and we will find that okay, 80 is the max. Why do we need this thing, right? So I'll tell you why do we need this. Because in terms of time complexity, now think about when we have the huge volume of data, okay, this makes a difference. Because even if you, let's say you want to search for this 8 size, let's say somebody is giving you that search between 2 to 6, right? 2 to 5, let's say 2 to 5, how many values are there? 2 to 5, there are total 4 values, right? So you have to 4 times check that what is the maximum, right? 4 times you would be traversed. But in the case of this, we are dividing every time in the half, right? So let's say you are coming from 2 to 5. So as soon as you came 2 to 5, right, this will be go to which range? It will go to this range as well as this range, right? Because 2 to 5 is splitting into 2. So 2 to 3 would be, 2 to 3 part would be called here, and 3 to 5 part would be called here, right? And every time we are dividing, right? So in this case, what is happening, we are dividing every time the things in half. So if, let's say, at any time if you have 8 possibility, then in case of segment tree you can do that in log base of 2 8, right? So in 3 iteration itself you can do, because range based we are dividing every time. See here, we divided into 0 to mid minus 1, 0 to mid, and mid plus 1 to right. This is 7, right? If we call this very right equal to this guy as right and this guy as left, okay, so you can see here this is left to mid and this is mid plus 1 to right. So that means we are dividing this every time. So range based search would be very faster in this case. If we are taking search in O of n, then in this case it would be O of log n, where base is 2, right? So that is why we are fine to use this segment tree first of all. Okay, now one more thing is we have to update certain thing. So update could be faster in the case of array itself, because when we go to update, again we have to search it in log n, right? But in case of array, we can directly go to update it, right? If we want to update 5th index, we can directly come here and update it. But in this case, we have to again look for the ranges. So in case of update, so look at the real life examples. For example, let's say we have kind of, when we do the, let's say we are working on certain bird pad, suppose, and we want to highlight a sentence. What we do is we right click over that, we select it and we click on the bold and it becomes highlight. So have you ever thought what is happening inside it? They are actually using the segment tree, because they are selecting certain range of text, and for that particular range only they are making it bold. Okay, so we cannot search one by one, then it would be very slower, right? So we have a lot of such usage of it, like even in the stocks, right? If we want to find the top leaderboard of the stocks, then we will make the range based upon hours or whatever unit of time, and we can directly fetch them. So there are a lot of real life implementation of segmentation tree. So that is why we need the segmentation tree. Okay, now this looks like a binary tree, right? It is binary tree because every node has only 2 child, not more than 2. It could be 0 or 1 or 2, but not more than 2. That means it gives a guarantee that this is a binary tree. And you guys know that a binary tree can be represented in the in a linear data structure like array, right? So a binary tree, if there is a n is the node, then who would be its left side? It would be 2n plus 1, right? And it similarly 2n plus 2 would be its right child, right? We know, right? For any binary tree we can represent in terms of array. So similarly we can do for here as well. Now one thing I want to discuss with you is like as I told you initially that it is taking that if size of it is n, then size of this array would be the size of this entire segmentation would be 2n minus 1, right? It looks like that because this was 8 here, size was 8 here, and total here you can see 2n minus 1. But guys, this is true only when we have the size of this nums in the perfect power of 2. Like in this case, What is the size? Size is 8. So this is basically perfect power of 2, because 2 to the power 3 is actually 8, right? So in those cases it can be 2n minus 1. But in general, if we want to take it for any size, if we want to construct a segment tree, let's say any size is n, okay, so this would be it could be anything, maybe perfect power of 2, or may not be perfect power of 2. So in that case, what we will do, we will create a size array of 4 into n. Now you might have a question that how the hell I can say 4 into n directly. There should be certain logic behind it. Let's say the size of this nums was n equal to 5. Then what would be the nearest possible value which is perfect power of 2? The next value which is perfect power of 2 would be 8, right? So this 8 we could have achieved, let's say, in previous value, if it was p, right, which is 4, right? If it was p which is 4, then if we want to get the next one, right, this should be 2p, right? This should be 2 times of p. Okay, now you guys know that this 2p could be go up to maximum of 2 into n, right? This could be less than or equal to 2 into n. Okay, now as we know that if it is becoming perfect square, okay, then we are getting the 2n minus 1, right? So suppose this 2p is our perfect square. In that case, how many nodes would be? It would be 2 into whatever is the number of nodes. So in this case 2p, right? So we could write it like this, 2p minus 1, right? It would be 2p into minus 1. So this would be 4p minus 1. Now you guys know that 4p can go up to 4n. So for that reason, to even there could be certain childs which are not perfectly having left or right. So but still, for the safer side, if we want to convert any nums of size n to a corresponding segment tree, we have to take it 4n, construct this segment tree, and this segment tree would be having basically 3 methods. One is to search. Okay, so search we want to find the range of 4 to 7. Okay, so see here, this is starting from 4 till 7. So what is the max? 40 would be max here. So here it would be stored like 40, right? We can see here. So if it is 0 to 7, answer should be 90. It is 4 to 7, then answer should be 40. If it is 0 to 3, then here also the answer should be 90. If let's say it is 0 to 1, then answer should be 20 here. Would be our this search method would be take the start index and the end index. And in this index we will find, so we can directly find it like 4 to 7 it is 40. Similarly, anybody is asking 2 to 3 it is 90. So this kind of thing. So one method would be search method, another method would be update method, and another first method would be build method. Build means building of the segment tree from this given nums. Okay, so see here, first of all I have written a class called segment tree. Okay, this segment tree class have two values, like this is int tree, which would be actually our segment tree, because you guys know that we are this is a binary tree, so we can represent it in terms of our array, right? So this is n. So see here, this is our constructor. In this constructor we are passing the value, the num, for which we want to convert it into a segment tree. Like in this case, this nums would be passed to the constructor of that class, so that we can build an equivalent segment tree. Okay, so this is what we are doing here. So you can see here, this is the n variable where I am taking the whatever is the length of it, and see here the tree I am creating here, tree equal to new int, tree is array only, so tree equal to new int 4 times n. Why 4 times n? We already discussed. Okay, so for the for safer side we are taking the higher values. Now we are calling this build function, so we will talk about what this build function is. Okay, so you can see very simple. So we are passing these values here which we have created here. Okay, this node is the node variable, the very first value. Okay, so in this case we are taking as 0. Okay, 0 would be our first thing, because we know that this answer would be, this segment tree would be in form of tree. So if let's say our parent node is at I equal to 0, okay, or let's say n equal to 0, node equal to 0 suppose, then its left child in the array would be residing at 2n plus 1, right? Left child, this would be indicating the left child, 2n plus 1. This would be left child, and what would be the right child? Right child would be sitting in the array 2n plus 2, right? This is very simple thing, everyone, all of us know. Okay, so left would be sitting 2n plus 1, right would be 2n plus 2. So for that reason, what we are doing, see here, build function. Yeah, so you can see here. So if left equal to right, means if it is given only one value, okay, in that case what happens, we are making this node, okay, node is starting with 0, so we are making this node equal to whatever is the value at the left or right. Left or right means there is only, this condition will be arise only when we don't have any left or right child. That means it would be only single value. Okay, so for single value this would be true when we are reaching to the leaf nodes. Okay, so you can see when left equal to right, in that case what is happening for this, you can see here, these are leaf node, left equal to right, both are 0, both are 1, both are 2, both are 3. So that is the case. So when left equal to right, whatever value we have, so node, tree node equal to whatever is the nums left or nums right, whatever is in the original array, and we are returning. So this is our closing condition of this build function, which is a recursive approach. Otherwise what we are doing, we are getting the mid, left plus right divided by 2. Now what we are doing, you guys know that we are calling on left child and the right child here. So initially we started at node, then its left child would be 2 into node plus 1, and its right child would be 2 into node plus 2, right? And we are calling these values. Nums is our constant array, and left and right. Okay, so here left, you can see here, when we started here, this left was 0. Okay, this is our left and this is our right. Okay, so left is 0, right is 7. Then our left child would become, what is 0 plus 7 divided by 3. Okay, so they are calling left on mid, and this is mid plus 1 and right. Okay, so same thing we are doing here. You can see here, we are calling on the left side, so it would be 2 into node plus 1 in the this tree array. Okay, this tree array, and left and mid, and here you can see mid plus 1 and right. So we called it recursively. Now you guys can see this is bottom up approach. Bottom up approach means first we are calling the recursive calls, and then after that we are making the sum. So tree of node equal to whatever is the max from the left child and whatever is the max from the right child. So you can visualize like this, that when we call our functions, okay, our functions would be being called like this, that it would be like from here we called, then immediately this guy would be calling this guy, then this guy, right? So it would be close here because left equal to right would be here. So from left equal to right, from here it would give 20, and from here it would give 10. So 10 from here and 20 from here. We will take the maximum value, so 20 will come here. Similarly, this would be go for all the nodes. So same way we are doing here. You can see here that the left child guy value and the right child guy value, whoever is the maximum, we are assigning to the parent on which we called this function. Like in this case we called on node. So similarly these would have been called inside these build functions, right? And that is why we have already filled. So that is why we are calling this would be a bottom up approach. We will write the search method. Search is like, it will give the start index and end index, and in this range we have to find that what is the maximum value. So this is my search range method. It will find the max value. Now I have written a search utility method. So see here, this is our search utility method. This node is the root value under which we want to search, and the left and right is anyway is the 0 and the n minus 1 of our nums, and L and R is the range where we have to find. So you guys can see this is important, that if R is right, it's okay, this guy is right. If right itself is lesser than left, okay, or left is greater than right itself, that means we are out of the range. For example, here let's say this is 0 to 7 and I want to search something between like minus, you can say, suppose I want to search in a range of 10 to 15. Okay, let's say I want to give left equal to 10 and right equal to 15. In that case, what will happen? This is not at all in our range, right? This would be somewhere out of this. Or similarly, we can have certain negative range, that also would not be in our case. So that is why what we are doing here is, if right itself is lesser than left, means they are on left side out of this completely, or even our left is greater than the right of it, then they are right side of this range. In that case, we are returning 0 because we don't have anything in that case. Okay. Or you can see here, this is also important. If our left is, okay, this range L, if L is lesser than or equal to left, but R is greater than or equal to right, means for example 2 and 5 is our L and R, okay, and you can say 1 and 4 is our left and right. That means it is covering totally, okay. So everything available that would be directly returned, which is sitting at the node, because it is covering everything in that range, okay. So in that case, we are directly returning, because at node we have already calculated all those max values. So we are calculating it, directly returning it. Otherwise, what we have to do is, we will get the mid pointer of it, right plus left, similarly like this here. For example, yeah, I want to clear one more thing. For example, let's say it is 0 to 7 and somebody is searching, suppose they want to search, they are giving a range of -1 to 20 suppose. So you can observe clearly that, yeah, this is falling, our left and right itself falling in this, right? This complete array is falling in this range. That means we have whatever is sitting at the node, that we have to return directly. So same thing we are doing here. You can see here, if this is the condition, we are directly returning whatever is there at the node. Otherwise, we have to look into left or right child. So see here, we have created the mid pointer here. Now we are finding on the left side. So left side would be 2 into node plus 1 and left and mid. And here this is the right side. In both of them, whoever is the maximum, we are returning that value. Okay. So this is our search utility, which is being used here. So we are done with the search function. Now we have update function also, because there could be the possibility that somebody want to update certain value. Okay. So updates are expensive in this case. They are taking log n, but in case of nums, they are doing O of 1. But anyway, our uses are very important for segment tree. So see here, in update, we are taking the index and the value. So at this index, we want to update this value. So what we are doing, we have written a utility method. So this utility method, what it is doing, this is our tree that we have constructed. And this is the node where we starting the head pointer, right? The one which is root of all of them. And left and right is 0 and the whatever is the size, okay, of this nums, 0 and n-1. And index and value is the one which we have basically passed. Now see here, if right equal to left, okay, the case that there is only one node, okay. So in that case, what we are doing, whatever is the value there, we are directly updating it and we are returning. Okay, so this is the closing condition of it. For example, if there is only one value, in that case, this would be the update value. We don't have to worry about any max because there is only one value. Otherwise, we have to take the mid pointer here and we will check that if index, the index where we want to update, if it is lesser than mid, okay, that means we have to check for the left side. We are checking update function on the left side. Otherwise, we are calling on the right side. So this also in the bottom up approach, right? We are updating here tree node, the parent value with the whatever is coming, whatever maximum is coming from the left and right child value. So this also in the bottom up approach. Okay. So all the three methods were bottom up approach here. Okay. Now what will happen is we are done with the build, update and this thing search, right? So now what we can do is we can, for example, we want to take, let's say this is our nums. Okay. Then what we are doing, we have created an object of segment class, segment tree class, and this is our S. Now we want to search between 0 to 3. So you can see here 0, 1, 2 and 3. What should be the max? Max should be the 90. So let me execute this code. So I am running this code. Yeah, it is 90. You can check for some other values also. Let's say we are checking for between 2 to 5, let's say 2 to 4, suppose 2 to 4. So this is starting to 3, 4. So again 90 should be answer. Let me make it 105, right? So 2, 3, 4, right? So 105 should be the answer. So let me execute this code. So yeah, so that means our segment is completely working fine. Now what I'm doing, I'm copying this all. Okay, I'm copying this all, excluding this main method, and I'm directly pasting it here in our this question. Okay, so see here, I have done so far nothing. I just copied whatever we have done here and just copied it till here. Okay, we have copied everything this inside this segment tree class. Now we are using it. Okay, so you can see here, this is our method of this question. Now see here, first of all, we are creating the segment tree, but we are creating the segment tree on the baskets, because baskets is the one where capacity resides. So we have created this tree, segment tree, right? So now what we are doing here is, like we have created a count variable and the whatever is the length of this basket. Now you guys can observe create here that we are traversing through the fruits array. Okay, now we are going in the binary search paradigm. Okay, so initially this would be the result index, and left equal to 0 and right equal to whatever is the size of this basket. Okay, now see here, while left is less than equal to right, we are getting the mid pointer. Okay, now see here carefully, we are doing the search right in the left and mid. Okay, so we are doing this search that, hey, the capacity which is in this range is greater than or equal to fruits I. So let's say if we found greater than or equal to fruits I, that means this could be the one value, but our tendency is to get the leftmost which fulfill this condition. Okay, so that is why what we are doing, I have made this result because this might be a potential result. So we are parking this value here, and we are further trying to get that, hey, is the one condition which is satisfied, is there somewhere some more value which is residing on left side, because we want to get the which is right first left value which is fulfilling this value, right? So what I'm doing here, I have stored the result, and right equal to I'm making mid -1. Okay, I'm decreasing the right side so that we can get as much as possible from the left. Okay, otherwise if this condition is not true, means the capacity is not greater than fruits I, that means we have to look somewhere in the right side. So what we are increasing this left equal to mid +1. Okay, now you guys, some of you might have a question that these are not sorted, why I'm doing this binary search. So bro, this is not on the binary, this binary search is not the traditional binary search. We have already constructed our segment tree. Okay, and this segment tree we have already stored value for the range based thing. So that is why we are using this search range stuff. Okay, and now we are checking in the left possibility that which is the least left, I mean the most left one which is fulfilling this condition. Okay, so now once we will come out, see here, once we are coming out this while loop, we are checking that in case if res equal to -1, that means we started res equal to -1, right? If it is not -1, that means we have found somewhere value. So we are checking that means this res index should be greater than fruits I, just checking otherwise, and then we are updating that value. So what this update method is doing, we have already discussed here. Update method was updating at this res index. So in this res index, the basket capacity I am making 0, right? So this update would be update to max value, everything in the range, right? That the one which we discussed here. So finally we are calling for every I. Okay, for every I we are calling this binary search, and we are getting the leftmost fulfilling values in this way. Okay, otherwise if we are not getting this condition, okay, you can see here, if res equal to -1 and basket I, this condition is also true, then only we are updating. Otherwise if that condition is not true at all throughout the array, then we are making count ++, because in that case we haven't found it anywhere. Okay, so if we haven't found it anywhere, that means that has to be miss. Okay, that guy would be missing it because we don't have any capacity. So we are increasing count ++. So we are counting the missing type of the fruits. So once we are done for this entire for loop, we would have the total count. So let me execute this code which I have already done. So guys, what would be the time complexity here? The time complexity here would be n log n. Okay, so Thank you for watching this video, and if you guys have any concern, please make a comment over there.